Trigonometric ratios of complementary angles, or also cofunction identities as they are called, are the easiest to understand. But still, if for some reason you feel overwhelmed by them, you need not worry because you have come to the right place. In this video, they have been explained in the easiest of ways, so come on, let's go. Hey guys, this is Vikas Sharma welcoming you on behalf of Exponent to Success to yet another video of ours. Exponent to Success is an initiative that helps to add an exponent to your learning curve. If you're new here or if you're landing on our channel pages for the first time today, I would strongly recommend that you subscribe to our channel right now so that you do not miss out on any future content from us. And do not forget to click on the bell notification also so that whenever any new content is uploaded, it comes right into your inbox. In the last video, we learned about Pythagorean square identities or trigonometric square identities. And if you happen to miss that video, the link to that is in the top right hand corner of your screen. Do click on that to be taken straight to the video. And do not forget to stick around to the end of the video because in the end, we are going to learn a very simple way of learning the trigonometric ratios of special angles. It's a very simple way, it's a very easy way, you won't ever forget them. So do stick around to the end of the video. In this video, we are going to look at cofunction identities, or also more commonly called trigonometric ratios of complementary angles. But before we jump into it, let's recall our very first video in this series in which we discussed the very basics of trigonometry. And if you happen to miss that video also by any chance, do click on the top right corner of your screen to be taken to the video straight away. So to learn about the trigonometric ratios of complementary angles, we need a right angle triangle. So let's take a right angle triangle. Let's give it a name. So let's call it, say, triangle A, B, C, and let's give the traditional name. So A is one leg of it, B is the other, and C being the hypotenuse or always the longest side, as according to Pythagoras, let's name that C. And let's call this angle here, I don't know what angle it is, but let's call it as theta or theta. And this we know is a right angle triangle, so this has to be 90 degrees. Now, if this is 90 degrees and this is theta, obviously you can work out what is this angle. So according to the angle sum property of triangles, we know that angle A plus angle B plus angle C is equal to 180 degrees. And if we have to find out angle A, but we know that angle B is 90 degrees and angle C is theta, that should be equal to 180 degrees. I can subtract 90 degrees from both sides of the equation. So I get angle A plus theta. That should give me 90 degrees, as 180 minus 90 gives me 90. And then I subtract theta from both sides. So I get angle A is equal to 90 minus theta degrees. So that means this angle right here is 90 minus theta. Let's find out the trigonometric ratios of these two angles. So one is a 90 degree, we don't have to worry about that. But apart from that, we've got two angles which are theta and 90 minus theta. So let us find the sine of that angle. So sine of theta, sine we know according to SOHCAHTOA, we never have to forget that. SOHCAHTOA, which simply means that sine is the opposite over hypotenuse, cos is the adjacent over hypotenuse, and tan is opposite over adjacent. So sine of this angle is opposite over hypotenuse. Opposite to the angle theta is A. So we write A over the hypotenuse, which is C. And the sine of 90 minus theta, so the opposite of 90 minus theta is going to be B over the hypotenuse, which is C. Let's find out cos. Cos of theta is going to be the adjacent, so adjacent side to theta is this. So it has to be B over C. And cos of 90 minus theta is again adjacent, so adjacent is this, which is A. So it has to be A over C. Tan is opposite over adjacent, or we can just say it's sine over cos. So opposite over adjacent of angle theta, opposite is A and adjacent is B. So tan of theta will be A over B. And tan of 90 minus theta, of angle A, that again would be opposite over adjacent. So opposite is B, adjacent is A, so it's B over A. Cosecant or cosec is, we know, is the reciprocal of sine. So let's just flip the numerator and denominator, so that becomes C over A. And in this case, for 90 minus theta, the cosec of 90 minus theta becomes C over B. Secant theta or sec theta or just sec of an angle is going to be the reciprocal of cos. So in this case, it would be C over B. And here it would be C over A. And the last angle we are left with is cot. Cot is the reciprocal of tan, so that will be just B over A and A over B. Now once we have found out these, do you see some common things in this? We see that these two are equal. 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 We see that, let me change the color here. We see that this is equal to this and that this is equal to this. Now let's copy that to a new page and let's see what we get there. Let's work out that in the other page. So we have got it here. Now if we find out the relationship, or what have we got out of this, let's see. So if you look at these two, we can say that sine of theta is equal to, or is the same as, cos of 90 minus theta. The other relationships that we can find out is that cos of theta is the same as sine of 90 minus theta. Then tan of theta is the same as cot of 90 minus theta. Or we can also say that cot of theta is the same as tan of 90 minus theta. And we can also see that cosec of theta is the same as secant of 90 minus theta. And the other way around, that the secant of theta is also the same as cosecant or cosec of 90 minus theta. So in short, these are your complementary identities, or trigonometric ratios of complementary angles, which are also called cofunction identities. And they are called cofunction because these are the complementary functions of each other. Now let's go back to the triangle that we had made earlier and let's see what we have. So we learned that if two angles, now in this case angle A plus angle B is going to be 90 degrees, because B itself was 90 degrees, so other two angles have to add to 90 degrees. That means angle A and angle B are complementary angles. So we can say that theta and 90 minus theta, and that is why we took it as 90 minus theta, because we know that both these angles are complementary, so this obviously has to be 90 minus theta. So these are complementary angles, and you see how we worked out the ratios of these. Now if you want to take examples, or if you want to take the trigonometric table, do you remember that sine theta or sine of 30 was 1 over 2, which was the same as cos of 60, because 30 and 60 are complementary angles. You remember that cos of 30 was root 3 over 2, which was the same as sine of 60. So based on this, let's try and do a few questions. Let's say sine of 53 degrees will be the same as cos of x. We have to find the value of x. Now using this identity, this cofunction identity, we see that sine of theta is the same as cos of 90 minus theta. That means we can say theta here is 53. So that means that the sine of 53 degrees will be the same as cos of 90 minus 53. Or we can also say that sine of 53 degrees will be the same as cos of 37 degrees, because 90 minus 53 is going to be 37. Now, if you want to confirm that, let's confirm it with the help of a calculator. Let's find out what the sine of 53 degrees is. So let's take 53 and take the sine of that. So that's going to give us 0.7986 something. So let me write that 0.7986 something. That should be equal to cos of 37 degrees. So let's clear this. Let's take 37 degrees and find the cos of that. And that also you see is exactly the same number, 0.7986. Can also be given questions such as that sine of A is say 5 over 13, and we are given that angle A plus angle B is equal to 90 degrees. That means both are complementary angles and we can apply one of these identities. So that means now there's no triangle, but we can say that sine of A will be the same as cos of 90 minus A. Now according to this identity, if we find the value of, if we subtract A from both sides, we get B is equal to 90 minus A. That means 90 minus A is the same as B, or we can say that sine of A is the same as cos of B. That is always the case. These identities will always work. These are called cofunction identities, or these are called complementary angles identities, the identities of complementary angles. Now there's no triangle given here, but let's assume that there's a triangle. We have been given a ratio. Can we just on the basis of this, we can find everything in that triangle. So let's say we have this side which is say 5 centimeters or 5 units. Let me just write that as 5. We have this side which we are given is 13, and because they are complementary angles or they add up to 90 degrees, that means the third angle has to be 90. So that means this angle is 90 degrees. Now we don't know what these angles are, but this angle is 90 degrees. We have one side is 5 because that's the opposite over hypotenuse. We know that sine is always opposite over hypotenuse because of the SOHCAHTOA. So that means opposite is going to be 5 and hypotenuse is going to be 13, and let's call this angle to be theta. Then obviously if we have these two sides, can we work out this side? Yes, we can. Using the Pythagoras theorem, we can work it out, which says that 13 square should be equal to 5 square plus x square, or we can say that x square will be 169 minus 25, or x will be equal to square root of 144, which will be 12. It could be both plus 12 or minus 12, but since we are talking about length of a side of a triangle or the distance between 2 points, it always has to be positive. So let's remove the negative sign. It only has to be 12. And let's try and find out what this angle is. Let's bring up the calculator again. We know that sine of 5 over 13. So let me clear this. So we've got 5 divided by 13, and that gives me 0.3846. Now let's take the inverse of that. So sine inverse of that is 22.619 degrees. Or we can just say that the sine of this angle or this angle will be 22.62 degrees, and if this is 22.62, then this has to be 90 minus 22.62, which will give us 67.38 degrees. And let's try and find out the cos of 67.38. Let's go the other way around. So cos of 67.38 is 0.384, which is the same, and which is the same as 5 over 13. So do you see how this will always work out to be the case? As far as we are concerned, we have already finished what we were supposed to do in this video, but like I told you in the beginning of the video, to stick around till the end of the video, because at the end I was going to give you a very simple trick about how to remember the trigonometric ratios of special angles. So let's learn how to do that. So I've got this table here which I want to complete, and the very simple trick is that you know that tan theta is nothing but sine over cos. Cosec theta is nothing but the reciprocal of sine, or I can just say 1 over sine theta. Sec theta is the reciprocal of cos, or 1 over cos theta. And cot theta is the same as 1 over tan theta, or the reciprocal of tan theta. So all we really want to remember are sine theta and cos theta. So the very simple trick about this is that you start with 0, 0, 1, 2, 3, 4. And here you start the other way around, 4, 3, 2, 1, 0. Then you start taking out the square root. So square root of 0, square root of 1, square root of 2. And then you divide all of them by 2. And when I simplify them, what I get is 0, 1 over 2. Root 2 over 2 can also be written as 1 over root 2. It's nothing but the same thing. This will remain the same, root 3 over 2. And root of 4 is 2, so 2 over 2 is 1. And just before we end, I'm going to leave you with another meme which I found, which was quite hilarious, and I felt it was quite related to the topic that we chose today. And if you see this, so if you commit a crime 90 times, you'll get caught only 45 times, because sine of 90 is the same as cot of 45. So let's see, the sine of 90 is 1 and the cot of 45 is also 1. So that's hilarious, isn't it? That if you commit a crime 90 times, you'll get caught only 45 times, because sine of 90 is the same as cot of 45. Or sine, they're taking it as sin. If you sin 90 times, then you'll be caught only 45 times. So that brings us to an end of the video. I hope you enjoyed the video thoroughly and you learned something useful out of it. In case you did, I would like to hear all about it. So just head down to the comment section below and leave in your comments for me. In case you are facing any problems with any of your questions, or in case you want me to cover any specific topic, just mention that in the comment section too, and I'll surely get back to you with a video. I would surely recommend that you hit on the like button below and share the video link with your friends so that they also learn something useful out of it. And in case you haven't subscribed to our channel as yet, this is the right time to do so. You see a subscribe button right in the center of the screen. Just click on that and you'll be subscribed to our channel straight away. And do not forget to click on the bell notification also, so that any future content is delivered right into your inbox. As a part of your continued learning, you can click on these videos shown on the left side here. Please like and share the video. Take care. God bless.